Hello, how are you all? Hope you're doing great today. It's rather gloomy outside today. It's not very sunny here. I hope the weather at your place is great and that you're ready to work with me. For those of you who do not know me, I'm Dr. Nandi. I frequently hold live sessions on my YouTube channel. I also have recorded videos on my YouTube channel on different kind of math problems. I also have some fun videos, some shorts. If you get a chance, please take a look at my channel. And if you like the videos, please give me a thumbs up. I really appreciate that. So, without further ado, let's get started. Just if you are wondering what am I going to work on today, we are going to work on a confidence interval for the mean for small samples. Okay, so without further ado, let me share my screen with you. 5 students were randomly selected. If I can move it up a little bit. And asked how many months have passed since they saw a dentist. Their responses were 6, 17, 11, 22, 29. Remember, these are the months that have passed since they saw a dentist. Find the 95% confidence interval for the population mean. As you all know, we do not know exactly what the population mean, but we can try to estimate an interval, that is an interval, a range of numbers with a lower boundary and an upper boundary within which most probably the population mean will fall. As you can see here, the sample size is only 5. And we are not even told whether this sample came from a bell-shaped distribution or normal distribution. The techniques that we are going to apply will require that the sample came from a normal distribution. The easy way to check this is to enter the data in list 1 of the calculator TI-84 and make a box plot. If there are no outliers either on the right or on the left, then we can conclude that this sample came from a bell-shaped distribution. So the first thing we will do is to clear the memories of the calculator. We do that by pressing the second button, then the plus button on the bottom right, and then number 4. Second plus 4 will bring clear all list on the calculator and hit enter. And it says done. That means the memories of the calculator have been cleared. Then we are ready to enter the data in L1. So we press the start button and then 1. Okay, stat and 1. Our cursor, the black rectangle, should be on the first line in L1. L stands for list. Remember, we are going to enter the data in list 1 and then make a box plot out of it. So we put 6, 17, 11, 22, and 29 in the list 1. Now we are going to make a box plot, a modified box plot. What is a modified box plot, you ask? It is the one which shows whether there are any outliers or not. So with the data in L1, after I've entered the data in L1, then I press second button and Y equal to button. Second button and Y equal to button. Second button and Y equal to button on top of it. Then we are going to press number 1. Highlighted on the top left is plot 1, that is the cursor is sitting on the first line in plot 1. Then the next line, the cursor is on. Okay, that should be on. If it is on off, bring it on. Then the next line, bring the cursor down on type and select the fourth type of chart. 1, 2, 3, 4. It is the modified box plot number 4, which shows us whether we have any outlier or not. Okay, and hit enter. So the cursor and the type should be flashing on the fourth type of chart. Okay. Now you press the zoom button. Zoom button is the third key on the extreme top row. Zoom and then 9. And you get a box plot without any outliers. Notice the boundaries of the box are Q1 and Q3. The left boundary is Q1, the right boundary is Q3, the vertical line in the middle of the box is Q2 or the median, and there is a left whisker. This is sometimes called box and whisker plot. Left whisker, left horizontal line, and there is a right horizontal line from Q3. However, there is no outlier. An outlier would be shown by a separate square box if there had been any. No outlier. So we can write enter the data in L1 of TI-84. Okay. Then press second button and Y equal to button on top of it. Then select number 1, which is plot 1. Okay. Next line, it should be on. Sorry, erase that. Okay, plot 1. And next line, it should be on. And then type should be 1, 2, 3, and 4 type of chart. This is the modified box plot. So we put the cursor on the fourth type of chart, which is the modified box plot, which shows if there is any outlier, which shows an outlier. As the name implies, an outlier is a number which is far away from the rest of the data. Okay. So after that, we selected type number 4, and then we will do zoom 9. Zoom button and then number 9. Zoom 9. And that will show us a box plot, which is a regular box plot. Okay. This is your box. This is your Q1. This is your Q2. And this is your Q3. This is your minimum. And this is your maximum. No outlier. Had there been any outlier, it would be shown by a separate box. No outlier. Okay. Now let's move this a little bit up. Since there is no outlier in this data, in the sample data, we can assume that the sample came from a normal population. This is compulsory. We have to prove with such a small number of data that the sample came from a normal population. Okay. Normal population means bell-shaped. Population frequency distribution is frequency histogram is bell-shaped. Histogram is bell-shaped. Okay. Once we have proved that, then we can use moving up a little bit here, and we'll change the color of the pen later on. Use T interval to find the confidence interval. Find the confidence interval for the population mean. Just if you are thinking that this is a long calculation, wait a minute. Do not leave right away. I will show you how to do this quickly. So we are going to use TI-84. Use TI-84 calculator. Okay. Remember, in data already exist in L1. Exist in L1. So what do? We press the stat button, then highlight test on the top row, and then go down to T interval, which I believe is number 8. Okay, so stat button, then we are highlighting the test on the top row. Highlight means move the cursor to the test on the top row, then scroll down to number 8, which is the T interval. Okay, now in the screen you have, so if I move this a little bit, you have T interval, because you selected T interval number 8. Input should be on data. So bring the cursor on top of data and hit enter. It should be flashing on data. Why, you ask? Because we have entered the data in L1. Input is on data. Next line will say list, already set up to be L1, where we have entered the data. Frequency is 1. Do not touch it. Neither do you touch the list. Sea level, remember it's an, sorry, let me, let, so sea level is change it to 0.95 if it is not already. So type in 0.95 for the sea level. That's the confidence level. And then you go down on calculate. Go down on calculate and bring the cursor on calculate. When you are on calculate, hit enter once only. Enter. On calculate, you are going to hit enter. So the answer you got is 5.79 and 20.21. So with 95% confidence, we can state that the population mean will fall will fall between 5.79 and 20.21. months. This is the population mean number of months after the last visit, since the last visit to the dentist. So this is the easy way to do it with the calculator. However, I will show you what is the difficult way, or not difficult. How did the calculator came up with these numbers? Okay, so the formula that is used by the calculator. Let me move this a little bit up. Okay, so on this, let's go on this. Okay, so let me show you. Hold your breath, okay? I will show you what the formula was used by the calculator. The formula formula for 95, formula for confidence interval. For confidence interval for the mean. Confidence, I made the mistake. Confidence interval. Confidence interval for the mean is x bar sample. This is sample mean. Sample mean plus minus margin of error. E is the margin of error. Margin of error. What is the formula for E? E is equal to T in this case, because this is a T distribution. T alpha by 2, since the sample size is less than 30 and the population standard deviation is not known, multiplied by S over square root of N. Okay. T alpha by 2 is the critical value of T. Value of T. 1 minus alpha is level of confidence, which in this case is 0.95. And alpha in this case is then 1 minus 0.95 is 0.05. This is the area in two tells. In two tells. So alpha by 2 is area in each tell. Each tell is 0.05 divided by 2 is 0.025. Also, this should be associated with a DF. Okay, DF. So what is DF? Is degrees of freedom. Degrees of freedom. This only applies for the T distribution. And this is equal to n minus 1. N is sample size. So you have the picture of the T distribution like this. Let's draw a T distribution. Okay. Oops. So let me make that straight. Okay. Let's go back here. That's T is equal to 0. That is the T distribution. Okay. For n df equal to n minus 1. In our case, df is 5 minus 1 is equal to 4 because the sample size is 5. Okay. So at the center, t is 0. Okay. And this is the central area level of confidence is 1 minus alpha, which is 0.95. This is your sea level in the center. And area in each tail is alpha by 2, which is 0.025. Okay, so now we need to find this. These are the critical values. This is minus T alpha by 2 for that degrees of freedom, and this is positive D alpha by 2 for that given degrees of freedom, which is 4 in this case. Okay, so need to find T alpha by 2, which is critical value of T for df T alpha by 2, and I should mention the df. For df in this case is 5 minus 1, n minus 1 is 5 minus 1 is 4. How do you do that? That's a good question you have asked. How do I do that? Okay, so we are going to use our calculator. Okay, second button, verse button after that. This is in the third row. So let's do it. Press the second button on the top left, then the verse button on the middle, third row, verse, and then you scroll down to number 4 if you have TI-84. Second verse, and then number 4, which is int t, inverse of t. Okay, hit enter. Okay, first thing it asks for is area. Area is the area in the tail is 0.025. So this area over here, alpha by 2 is 0.025 is the area here. Okay. So area is 0.025. You're typing it in. Okay. Degrees of freedom, sample size minus 1. So df is 4. Type in 4. Then you go down to pest. Whenever you're on pest, hit enter twice. Enter twice. Enter twice. Okay. Enter. And then again enter. And the answer is T alpha by 2 for 4 degrees of freedom. Okay, df. Or you can write T 0.025 with 4 degrees of freedom is equal to what the calculator tells us. We will take the positive value is 2.776 is 2.776. Although it gives a negative value, it's on the left. On the right will be the same value without the negative sign. So this is the value we are going to use to get margin of error. Remember, margin of error is equal to T alpha by 2 d, df multiplied by s over square root of n. How do I get the s, you ask? Well, you can do stats. You do stat, calc, highlight calc on the top row, then select number 1. Let's move this up a little bit. Okay. So, okay. So stat, calc, number 1 is 1 var stats. So this will lead you to 1 var stats. And list is L1, leave it alone. Frequency list is the second line in that screen, should be empty, nothing there. So it's empty. If there is something, clear it. And then go down to calculate. Calculate, put your cursor on calculate and hit enter. Hit enter. Why do you do that? Because you're doing the descriptive statistics. So your sample mean x bar. So x bar is the sample mean. Sample mean is equal to 17. And you need the sample standard deviation. Sx is 9.028. We need this to calculate, uh, and you already know n sample size is 5. We need these three information to get the margin of error. We already know T alpha by 2, T alpha by 2 degrees of freedom. So if I move the screen a little bit down, this is the value. Let me circle that. We need this one. So we need this one. We need this 2.776. We need this value for T alpha by 2. Okay, and we have to plug it in this equation along with s and square root of n. So let's do it. So let's go down and calculate the margin of error. So maybe I can change the color of the pen to make it a little interesting. Instead of the dull black, let's use this color. So margin of error, if I move this a little bit more, remember T 2.776. So margin of error E is margin of error. Margin of error is equal to uh, T alpha by 2 degrees of freedom multiplied by S over square root of n, which is T alpha by 2 was 2.776, which I got from the calculator. That is to be multiplied with S, which is 9.028. The whole thing is to be divided by square root of 5. Okay, so how do you do that in the calculator? In TI-84 you do 2.776 multiplied by 9.028 divided by second x square, gives you the square root. Inside the square root you type 5 and enter. Okay, so let's do the calculation. 2.776 is the critical value of t. Multiply that by the standard deviation, which is 9.028. Divide that by second x square, which gives you, it's important that you do second x square after division, because you want to bring in the square root. Inside the square root you hit 5. And the answer is 11.208. So is equal to, so E works out to 11.028. So what's your confidence interval? If I move this a little bit, is remember x bar is 17, right? So 95% confidence interval for the mean. Interval for the mean. For the mean is x bar minus e is the lower boundary and x bar plus e. So we already know x bar as 17 minus 11.028, comma 17 plus 11.028, and that will bring us to 17 minus 11.028 is 5.972. So we write here, no here, no here. 5.972 is the lower boundary, comma, and the other one is 17 plus 11 is 28.028. So with 95% confidence, we can state we can state that the population mean will fall population mean between will fall in between 5.97 and 28.03. Does it match with what we got with the calculator? Let's check it out. Stat test t interval. Enter, input is L1, okay, data rather, and we calculate. Okay, a little bit different. It was 5.79 and 28.029. Okay, 11 to 11 here, 28.0203. Okay, so in that same ballpark, but let me check on one thing. So we do second verse in t a 0.025 degrees of freedom, sample size -1 is 4. Paste, enter. Is 2.776 clear? Yeah, 2.776. And we do stat calc 1. This is L1. I'm just checking and making sure that the sample standard deviation is 9.0277, which is 9.028 maybe. Yeah, divided by. So 2.776 multiplied by 9.028 divided by second x square, sample size is 5, and that margin of error is 11.2. So we have done it correctly. We are in the correct ballpark. So if I go back and check what I got with the calculator, I got 5.79 to 20.21, or stat okay, stat test and t interval. I did enter. Input is data, list is 91, 95. Calculate 5.79 and 28. So 5.79 and this is 28.21. That was my mistake. So if I may change the color of the ink. So let me change the color of the ink in this case. Move it back to pink. Okay. And then we go to here and it is 28 point, not 20.21. That was my mistake. So let me fix that. That is 28. So let me erase it first. Should erase it. So now going back, it's 28.2, comma. So notice how it is written 5.79, then comma 28.21. So 28.21, not 20.21. So this should be 28.21, 5.79 and 28.21. Now with the formula we get, what do we get? 5.97 and 28.03. Close enough, close enough, but not exactly the same. Why, you asked? This is because of some rounding going on. So my suggestion is, if you have a TI-84, if there is no restriction in your school that you cannot use TI-84, use TI-84 if there is no restriction, and do stat test and T interval. Enter the data in L1, check to make sure you get a box plot, modified box plot without any outlier. That means the sample came from a normal population, and then you use stat test T interval and plug in the numbers and get the interval. If you want to use the formula, in that case, you have to calculate the margin of error. Margin of error is given by this T alpha by 2 with degrees of freedom multiplied by S over square root of n. Now, T alpha by 2, degrees of freedom is sample size minus 1 is 4. Okay, so T alpha by 2 will be obtained by from second verse 4 in T. Okay, and it works out to 2.76776 multiplied by standard deviation is 9.028 divided by square root of 5. That gives us some numbers which are very close but not exactly the same as what you get from the calculator. If you ask me which one to use, if there is time restriction and if you do, there is no restriction in using the calculator, go ahead and use the calculator to get the T interval. Okay, that's my suggestion. If you have any question, please do not hesitate to ask me and shoot me a question, and I'll get back to you as quickly as possible. If you like this video, please give me thumbs up. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. You will find lots of helpful videos, and I look forward to seeing you tomorrow. Thanks for watching this video. Take care. Have a nice day.